Okay, students, we're going to talk about solving exponential equation inequalities. That would be where they intersect, or the point of intersection again. Okay, or for the inequality, it'd be shaded region. Okay, so as we see right here, it says all the properties of rational exponents that you know also apply to real exponents. So rational means it can be written as a fraction. You should know that inside and out by now. If not, you have not been paying attention in class and trying to remember anything. Okay, all right, remember that. A to the m times a to the n equals a to the m plus n. I will never say it like this. This is how you memorize it. When I ask you, when you multiply like bases, what do you do to their exponents? Your answer, you add the exponents. Remember, a is called the base. M and n are the exponents. So when you multiply like bases, that means the same. You add the exponents. That's how you remember that. This one you remember, I'll ask, what's the rule for power to a power? You multiply the powers or the exponents. What do you do when you divide like bases? Your answer, you subtract the exponents. That's what I want to hear. You better have those memorized. You should know that from Algebra 1. Okay? You need to learn your vocab, say it correctly. You know what the teacher's talking about. You're going to hear all this again in college. Okay, in your next math class, we're going to pre-calculus and or calculus. Your teacher expects you to know this. All right, property of equality for exponential functions. If b is a positive number other than 1, then b to the x equals b to the y if and only if x equals y. That should be common sense. We get the like bases, which means then the exponents must be the same in order for the answer to be the same. Okay, so why are they telling you that? The point is if I can get it to a like base, then all I have to do is set whatever these two exponents are to equal to each other and solve. That's the whole point in them telling you this. So the goal is to make like bases here. So notice that's a 4 and that's a 2. Those are not like bases, but I can change one of them into the other. Okay. There's two ways of doing it. I can either go 4 down to 2 squared to the x minus 1. Okay, 2 squared is 4. Now I'm down to base 2. And remember, power to power, you multiply. Okay, so you'd have 2x minus 2 right there equals 2 to the x plus 5. So again, we have like bases, so we set the denominators equal to each other. So x plus 5 equals 2x minus 2. Subtract the x across, add the 2 across, and you get x equals 7. Okay. Now, the other way is if I want to change the 2 to a 4. Okay. What would I have to do there? I'd have to square it. Most will always go down, like 4 down to 2. Okay, like this, because usually you're going to go to the smaller base every time. Okay, let's see if I go, to the x plus 5. I'll have to think about that. I'll always go from the bigger to the smaller right now. Okay, let's go to number 2. Write an exponential function whose graph passes through the points 0, 3, and 481. Notice exponential function. That means b to the x automatically. Whose passes through 0, 3. Okay. Now, exponential function. You can have a b to the x as well. Okay. So I can recognize then One is doing it by hand. Okay. The other is I can actually plug this right in a calculator and get my answer. Question is, what do I want to have you do? Save time. I might work one out in class. I don't want to work out the whole thing here and take up the amount of time on the video to do it all by hand to show you. So we're going to plug in the calculator. Let me show you how to plug in the calculator. Graphing calculator. Okay. So remember, when you get points, we always use stat, edit, to plot the points. So notice it was 0, comma 3, and 3, comma 81. Let's just verify that. Make sure I didn't mess that up. 481. Okay, good thing I checked. So I always check. Otherwise, you blow your whole answer. Okay. Stat, calc, and we want a exponential function. So we're going to look for exponential regression right there. 0. Board number 10, basically with 0. Exponential regression. L1 and L2, that's where we plugged them in for the x and y coordinates. So just hit enter, enter, enter. And there you see your answer. A equals 3, because here it tells you the form, y equals ab to the x. So you have 3, and then parentheses 2.279507, parentheses to the x. That's your b value. Okay, now they might tell you to round to the nearest hundredth, be 2.28. Okay. As far as doing that, so we look back at the answer that they have here, and then went to the thousandths, 2.280. Okay, and then there's my equation. Now, what is wrong with this right here? It said write an exponential function. So when it says function, that means it should be written in function notation. So this y should be the f of x, and the reason it's x because we have x over here. So technically they did not write it right. Okay, so you to write it right. Okay, you learn to follow directions. Okay, so you found errors as we've been going through these videos here on how they've written things, using wrong wording, etc., or wrong notation. So if it says right, go ahead and use your graphing calculator, put in function notation like that, and there's your answer. Go ahead and round to the nearest thousandth, even though I didn't tell you because that's what they did here in the example. So go to the nearest thousandth. Okay. Usually when they have you do it by hand, it's going to come out to a nice number, unlike this here. So that's why I'm just having you go ahead and put in the graphing calculator. If I knew that they were going to come out to nice numbers, I'd show you how to do it by hand. Okay, so that's what you're doing on this bottom half right here. Just put those in the calculators like I just showed you right there. First half, you are getting down. So just so you know, 8 is not a power of 4. They're both powers of 2. So you're going to write that as 2 squared, and that is 2 cubed first, and then to their exponents on each from there, and then set the exponents equal to each other, just so you know. If it's a reciprocal, again, 4 goes into 16, but 4 does not go into 8, so we're going down to 2 again. So all right, that is 2 cubed, and this, and 16 is 2 to the 4th, right? Well, this is the reciprocal. What does that mean? So that's 2 to the negative 4. 2 to the negative 4 is 1/16. Remember, I got to get like bases, both like bases of 2 right there. Okay, so there's examples of how to do that on that side. Let's go to the other side. Solve exponential inequalities now. Okay, so now ends up being inequality. So again, I do the like basis. 5 does go into 125. 5 cubed. So 5 cubed is 125. So therefore, 1/25 would be 5 to the negative 3. Remember, that's the reciprocal. Negative means reciprocal. So I see 5 to negative 3 there. And again, I go ahead and have my exponents set equal to 2x minus 1 is greater than negative 3. Add the 1 across, negative 2 divided by 2, and I get negative 1. Don't forget, if I divide by negative at some point, I have to switch to inequality. If you ever do that, multiply or divide by negative. You should already know that from Algebra 1 and earlier in Algebra 2. Let's see. So just remember, really, whenever they're reciprocals like this, you're looking at like 3 goes into 27, so it's going to be 3 to the negative 3 there. 3 goes into 243. Well, 27 times 3 is 81. 81 times 3 is 243, so it'll be 3 to the negative 5. Okay, and then you got to raise that to the power of the 3x minus 2. So again, power to power, you multiply. Again, power to power, you multiply. Okay, and then if you end up dividing by negative, you have to switch the inequality sign. That's why I always suggest, and I've always taught you in geometry all the time, move the lower number over the higher side, so you always end up with a positive. Okay, so you're never dividing by negative. Okay, you can if you want, just more chance for error. All right, that goes ahead and does the work for this one.